Hi, I'm Desiree. This is our quantitative lit class in Module 3, Statistics. Start off by demonstrating the formulas. Our first problem is about America's attitude towards climate change. I'll call it the Obama era. It's about two comparisons of two questionnaires from spring 2010 and fall 2015 about how people felt about climate change and what their attitudes were during those two different years. As you can see, it greatly increased in fall of 2015 compared to spring of 2010. These are the pie charts that reflect the statistics in the data tables, as well as the bar graphs. It's just a different way of looking at the data, 3 different ways. The degrees of 360 would show somebody how to partition a line on a pie graph, how many degrees. Would greatly help with that technique. Again, these two upper charts that show spring of 2010 and fall of 2015, as well as the pie charts and bar charts for this matter, convey responses from questionnaires of people on their feelings of global warming. The pie charts and bar charts were easy to create and that they can just be highlighted and the data can be transferred over. And another way to view the data, if one looks at the year 2010, they'll see the responses from people are much lower than they are for 2015. A possible outlook I came up with here is that we just came from a Republican president, Bush, a couple of years prior to 2010. This was Obama's era. By 2015, I feel Obama and his cabinet may have had a lot more evidence and influence at the time than they did 5 years prior to show the US and the world that global warming is not a hoax. The question is, from what you've read and heard, what are your feelings of climate change? The winter temperature during those 5 winters could have been warmer each year, and this could have changed people's feelings towards this very political issue. The data clearly shows how people became more educated over that era on climate change and global warming. Thanks, Obama, you're a shining star. It's tough living blue in a red state. The pie charts are easy to read, especially since they have data callouts. The degree column on the side of the data boxes again show one how many degrees to move their line on a pie chart. And to number one. Number two are just comparisons of two sets of data for two girls that had about 10 missing classes. And then the second one is heights of Army recruits and random mall shoppers. They show the range, median, mean, etc. on all four of those sets of data. As well as whiskers and scatter charts. These data boxes show a couple of students in several of their missed classes, as well as heights of miscellaneous shoppers and recruits in the Army. They convey range, median, etc. First, to find the range, one will take the data to the left of each box and subtract the highest to the lowest. Median, mean, and standard deviation will be the full data set of numbers included in each category, where the mean is the average. The coefficient is divided by the standard deviation. Next, the scatter plots are put in. Trend lines show how data follows it a little bit, especially in heights and the Army recruits. That's a very good example, actually. It follows right along the line, the Army recruits, where if you look at the other three charts, they're kind of all over the place. And the trend lines seem to help guide somebody to look at the data a little bit better. The trend lines may differ. If one compares the top two charts, they'll notice coefficient is a lot different, and this disturbs the trend line. The standard deviation in the first set of data is smaller and allows for more snug fit with the trend line and numbers. Just browsing each data set, one will notice the fluctuation in each category. Box and whiskers help one to see quartiles. This also helps onlookers see the median in both boxes, and whiskers and scatter chart is the same in the Army recruit examples. The quartiles we found Q1 and Q3 easily by median in each center. Basically, the boxes are simply showing where the quartiles and interquartiles ranges are located. One will notice the variation in sizes in the boxes on the box and whiskers because of the varying heights between the mall shoppers and steady heights of the recruits. The range is just different. Let's see, on to number two. Number three. This was an IQ test psychology experiment for a class. It's a full data set of a psychology class and their IQ scores in an experiment. Of course, the range and median and mean are all calculated for you. The scores run down the slide in order. The line in the middle of the blue box is right over 100, which is the median in this case, 103.5. And the whiskers on either side showing lowest to highest in IQ scores. An outlier is a number, big or small, outside all other values in a data set. Percentile means the higher the data, the higher one's score. The rank is the opposite, which means the lower the number, the better someone did on their IQ test. The Q1 and Q2 scores were also calculated, which convey the median of the upper and lower scores, and the upper and lower bounds are the outliers. The bell curve in this case is based on the mean and standard deviation, where one can see the mean at about 106 or 107, which is about 105.7. Also, one can notice a huge fluctuation in the bell curve if any of the numbers are changed for the IQ score. For instance, the more numbers plugged in, the less of a bell there will be as it begins to straighten itself out and move. Number 4, dam capacities in the US and South America. In South America, the standard deviation and coefficient are much different compared to that of the US. The US has more dams, but less range than South America. Our variation is less than half of that, actually, of South America. If one views the scatter chart for South America, they will notice dots down the 50,000 line. The essence of this conveys the average of cubic yards of dams at one point, or Q1. One will also notice that the dots represent from the data tables 56,563, 1, and 3. This is just one example, and one can view this all over both of these plots. One can also see the outlier in South America chart, which is 311,539. Both sets of data for both countries show range, median, etc. They both convey Q1 and Q3 components, we just went over. That's the end of number 4. Number 5, another IQ example with a mean of 100 and a standard deviation of 15. This is an example of an IQ test with a mean of 100 and 15 for the standard deviation for the bell curve. Z-scores here represent average distance between test scores. The Z-score, for instance, of -3 over here is 55 on the columns on the right. The percentiles are also completed over on the right, where the column runs downward. Almost all of the students reached the required score of 70%, which was about 976 students. Over on the right, the purple boxes show that 21% of the students were in the 20th percentile, 60% of the students were between the 20th and 80th percentile, and so on. Standard number 5. Number 6, reaction time of adult subjects and their alcohol level, 0.08. So range, median, mean, reaction time over here, and 3 charts. I called them the legal limit, Mothers Against Drunk Driving, and Let's Drink O'Doul's. As in the previous examples, the example begins by explaining range, median, and mean of reaction times of 25 people who are over the limit of alcohol consumption. The standard deviation in this instance is fairly close to the average. It's kept pretty tight rather than all over the place, and this makes it for very reliable data for the first chart anyhow. Each of the histograms conveys so many sorted reaction times from the top left, 25 people. The first histogram shows someone the real original data of the 25 unlucky people, may be pulled over for a checkpoint. However, the data in these charts are in ranges rather than listed individually. They're in bins. Some of them, the first one I think had 7 and then 4 and so on. The second chart wants to convey how people seem very intoxicated for a mad campaign, possibly, but the data is clearly made out to be erroneous because it has inappropriate ending points. The third chart is made to look like everyone is different and most do not get intoxicated in this scenario. The histogram does not begin at 0, it begins at 1. So always check to make sure that the ceiling is where it's supposed to be, and also verify axis begins with 0 for the validity of your graphs. Thank you.